Hello students, let's start off with integration by parts rule for definite integration. So if you look at the formula, you'll see that the formula is almost the same. In fact, the same formula for u into v. The only difference is there are limits. And here you have u integration of v dx, and you put the limits a to b minus integration of, again you have the limits here, and inside you have du by dx integration v dx and the whole dx, and the concept is same. You use ILATE as your benchmark, so you just have to make sure that the one which comes first out of the two functions in ILATE will become u and the other one will become v. So I, as we know, is for inverse, and for inverse you have sine inverse, cos inverse, tan inverse. L is for log, ln x, right? A is for algebraic, so you have x square, x cube, any polynomial equation. Trigonometry, you have sine x, cos x, and rest of the uh, terms. And exponential, you have e raised to x, a raised to x, 5 raised to x, and all that. Okay, so this is integration by parts rule, and let's start off with some questions of integration with parts. So we'll start off with the first one. So let's say we have the question as integration limit 0 to 2 x e raised to x. So the first thing which we realize here is that we are not able to substitute anything, nor we are able to solve this by the usual method. So what I'll do is I'll use UV rule. Now according to the UV rule, algebraic is this and this is exponential. So ILATE, this comes first and this comes second. So this is u, this is v. Now I'll just apply the formula. So what is the formula? You make this box, you write u into integration of v dx. You close this box, you put the limits, then the subtraction sign, then you have limits 0 to 2 du by dx, so derivative of x, which is 1. So let's write this, and integration of e raised to x, which is e raised to x, the whole dx. Okay, next step, you put the limits here, you put the limits. So what you have, so in fact first what I'll do is I'll let me solve this first. So integration of e raised to x is e raised to x, so you have e raised to x, and then you put the limits 0 to 2 minus an integration of again e raised to x, so e raised to x and the limits 0 to 2. Now let's put the limits, so 2 e raised to 2 minus 0, and here you have e raised to 2, and let's make this bracket, and e raised to 0. So what you have is 2e square minus e square, and e raised to 0 is 1, so plus 1. So finally the answer is e square plus 1. So this is the answer. Okay. So very simple process. Just apply the formula, identify the type, and apply the formula. Okay. Let's try the next one. Let's say the question is integration 0 to 1, and now you have x tan inverse x dx. Okay. So according to the UV rule, inverse is this and this is algebraic, right? So inverse, so this will be u, and algebraic, this is algebraic, so this will be v. So let me just rearrange to avoid any confusion. So tan inverse x dot x dx. Okay, let's start off with the formula. So we'll make a box here, then you have u integration of v dx and the limits 0 to 1, 0 to 1, then minus sign, integration 0 to 1 du by dx du. So derivative of tan inverse, derivative of tan inverse is 1 upon 1 plus x square into integration of x, integration of x is x square by 2 dx. Okay, now let's integrate this part. So you have tan inverse x, integration of x is x square by 2, and the limits 0 to 2 minus, now let's try to solve this one. So let me take this half outside, and here we have x square upon 1 plus x square dx. Okay, so let's see how we can solve this integral. So now this part is simple. This part is simple. We can solve this easily. Okay, so I can put the limits and solve this part. So let me solve this one first. So I'll just put the limits. So we'll have tan inverse, so this is 2 square, so this will come here. So you have 2 square upon 2, which is 2. So you'll have 2 tan inverse 2. And when you put 0, the whole thing will become 0. Okay. So, okay. So I think there is just one error which we have made. This limit is not 2. This is 1, right? So let's change that. So this is 0 to 1. Okay. So when I put the limits, so tan inverse 1. So tan inverse 1 into 1 by 2 into 1 by 2. So this part is sorted because now when you put 0, this will become 0. Okay. Minus, now let's try to solve this one. See, how will I solve this integral, this one? Okay. See, what I'll do is I'll try to manipulate and see how I manipulate this. So what I'll do is I'll write here a plus 1 and a minus 1. The reason I do this because I can clearly see this matches now with the denominator. So what I'll do is I'll write this half here and let me write the limits as well, 0 to 1. Okay, so 0 to 1. Now I'll split this. So what I'll do is I'll write x square plus 1 upon x square plus 1, which will become 1 minus 1 upon 1 plus x square. 1 upon 1 plus x square dx. Now we can solve this. Now tan inverse 1 is what? 45, that is pi by 4, because tan of pi by 4 is 1 into 1 by 2. So this part is done, minus half. Now integrate this. So see, 1 integration is x minus 1 upon 1 plus x square. So integration of 1 upon 1 plus x square is tan inverse x, and the limits 0 to 1. Now this will become pi by 8 minus half into integration. Now let's put the limits. So 1 minus tan inverse 1 is what? Pi by 4. And when you put 0, this will become 0. Tan inverse 0 is also 0. So I think we're done with this. So now we have pi by 8, and here we'll have one more pi by 8. Right, this half will go here, minus half. So pi by 8 plus pi by 8 will become pi by 4 minus half. So this is the answer, right? So hope you understood this type. Nothing great about this. It's just simple indefinite integration type of sums where we have just used the same formula in fact and just made sure that we had applied the limits. So hope you enjoyed this video, and till next time, take care. Bye bye.